Richard James will continue these tutorials on factorization with Factorisation Tutorial 1C. The next expression has two components. However, we already have a tip in solving this problem by the enclosure of the first component in brackets. And as we progress through these tutorials, I will have other things to say about problems that the examiners give with portions already enclosed in brackets or portions already factorized. The three terms in the brackets do not have a common factor. That tells us that it is a trinomial. So this expression is a trinomial that we have inside of these pair of brackets, and we need to factorize this expression as a trinomial. So we are taking all of those three terms together as the examiners intend us to by the enclosure that we have in these brackets. We will therefore attempt to resolve its middle term into its two components. Let us coin the general form of a trinomial in order that it will have a close resemblance to our trinomial. And we know that generally we say that it is ax squared plus bx plus c. This trinomial is a bit different because it is not consisting of x alone. Therefore, what we are accustomed to, we will adjust our general representation of a trinomial to resemble the one that we have here. So we will have, no doubt, ax squared plus bxy minus c y squared. So there we have the trinomial coined in a way to resemble our general representation of a trinomial, but giving consideration of the fact that we have x squared, xy, and y squared. There we have it. The procedure is the same. We still need to determine the two numbers that have a product of AC and a sum of B. We still need to determine the two terms that have a product of AC as always and will have a sum of B. We therefore need the two numbers that will give the same product as what is C here. The coefficient that we have here is -1 and the one that we have here is 2. So when we multiply, having our product AC, we are taking the coefficient here, which is 2, which is A, and the coefficient here, which is -1. So we multiply 2 by -1. We therefore need the two numbers that will give the same product as 2 times -1, which is equal to -2, and will give a sum of +1. The coefficient of x squared, which is A in this particular case, is 2. And C, the one at the end, the coefficient of y squared is -1. Multiply them, we get a -2. And the sum, which is the middle coefficient, is +1. As discussed in tutorial 1B, the product is negative. The numbers will have different signs, and the sum is positive, tells us that of the two numbers that have different signs, the larger one is positive. So the product as we have here is negative, telling us that the two numbers will have different signs. The sum is positive, tells us that of the two numbers that have different signs, the larger one is positive. Since the product is negative 2, we have only one option for the value of the result. For integers, only 2 times 1 will give 2. Therefore, that's the only option that we have, 2, 1. The sum is positive, therefore the larger one is positive. They have to have different signs. Do not forget that the product is negative, therefore they have to have different signs. But the sum is positive, the larger one has to be positive. So we have a positive 2 minus 1 is a positive 1, and that will be the coefficient, of course, that we have already as the coefficient of the middle term. But the two middle components will have coefficients positive 2 and negative 1. So those will be the two coefficients of the middle components. We have resolved the middle term of the trinomial into its two components. We may therefore proceed to factorize it, which is the trinomial that we have converted into its quadratic form by resolving its middle term into its two components. We will continue to factorize. And the first two terms have a common factor of 2x. So taking these two together, we have a common factor of 2x. There's no doubt that we can see 2 is a common factor, and also x is a common factor. So take the common factor and, as usual, divide each term by the common factor. So 2x squared divided by 2x, 2 will cancel, and x into x squared is x. And we have 2xy. 2xy divided by 2x. The 2x will cancel with the 2x. Y remains. There we have x plus y. The second pair has a common factor of negative y. Do not forget that we always use the sign that begins the second pair. So the sign that begins the second pair right here is a negative sign, and we can see that y is common, negative y. What do we do next? Negative xy, because after identifying the common factor, we divide each term by the common factor. So we take a negative xy here, and we divide by the common factor of negative y, and we get y's will go, and we have x left. But do not forget that negative divided by negative is positive. So we have negative divided by negative is positive, and the y's will cancel. So we will have x remaining. And we have negative y squared divided by negative y. Negative divided by negative is positive, and y into y squared is y. The other component will return as it is, or as we have done so far. The other portion we return as it is. So we are factorizing the trinomial, the first part, and then we are allowing the other part of the expression to tag along. Only the essential steps were written. The intermediate steps were not included. They were explained in the same way that we would expect a candidate to take those steps mentally. So instead of what we have done on some previous occasions, include the intermediate steps where we actually see that we are dividing each term by the highest common factor, we have not done so on this occasion. However, we have to show something for it, because I am making a step mentally. If I cannot explain the step that I am taking mentally, then it is not going to be clear. Therefore, we still have to have some representation of it in the slide, as we have right here. There we have them. But we are just demonstrating them However, we expect that those steps will be taken mentally. We will finish the factorization of the trinomial by taking a common factor of x plus y. So where we have taken a common factor of x plus y, what will happen? The other factor will be 2x minus y. So x plus y, and the other factor is 2x minus y, and it goes right there. Again, the second component will return as it is. We are not ready for it as yet. As a matter of fact, we are now at the stage that we may make use of it. There is an obvious common factor of 2x minus y, and we will throw in the intermediate step, dividing the expression by 2x minus y. So there is an obvious common factor of 2x minus y. Here we have the 2x minus y evident as a portion of our first bit that we factorized, and then we have 2x minus y occurring here. Therefore, we are sure that 2x minus y is common. So this is our original term, and we are dividing each one by the common factor of 2x minus y. So 2x minus y will divide into each portion. No doubt we have the common factor right there, and right here we have those two will eliminate each other when we reduce the fraction. And what do we have next? When we reduce the fraction that we have right there, the result is, well, some students will say that when something cancels, it goes away to 0. But we know differently. Any number or expression divided by itself is equal to 1. So this other fraction will reduce to 1 because we are dividing 2x minus y by 2x minus y. Our factors are therefore 2x minus y and x plus y plus 1. Here we have another expression that we need to factorize, and we may be a bit distracted by the 4x squared. The other expression may be factorized by simply taking a common factor. For sure, it is not a difference of two squares, although some candidates may be deceived by the fact that the first term is a perfect square and that the sign that separates them is a negative sign. So, sometimes we find students do that because of students given a bunch of expressions to factorize, and in the end we have something that looks like an attempt to factorize a difference of two squares when the expression is one that looks somewhat like this. And we are sure that it is not a difference of two squares, because although the first term is a square, which is a requirement of the difference of two squares, we have a negative sign separating them, which is another requirement of the difference of two squares. But this final term is not a perfect square. Therefore, we do not have a difference of two squares. However, it is very clear that we have a common factor of 4 here and also a common factor of x. So our common factor is 4x. And after taking a common factor, what do? We always divide each term by the highest common factor. 4x squared divided by 4x, the 4's will go, x into x squared is x, and negative 8x divided by 4x. 4 into 8 is 2, the x's will cancel, and positive into negative is negative, so there is our negative 2. This is how it is expected to be done in an examination. Also, the previous problem was solved and the intermediate steps were not included as a part of the solution. They, however, had to be written because there is no way for me to take steps mentally in a tutorial in order that the viewers will understand without giving indications. So it's really not my intention to put this down, which is somewhat of a representation of the mental process that a student is expected to carry out. So this really should not have been here, but should have been just a mental process. But there's no way that I can demonstrate a mental process. I will actually have to put some physical representation of it, and that is what we will have in these tutorials. Sometimes we have the intermediate steps included to keep you reminded of what the intermediate steps should be. Sometimes we have them just a mere representation of those intermediate steps, indicating that those steps should really be taken mentally. But whatever we do, we cannot do it without some form of representation in order that the viewers will be aware of the steps that are taken. Here we have another trinomial. For the trinomial that we have here, the product of A and C is, what is A? 4. What is C? Negative 21. 4 multiplied by negative 21, and we did not write the answer down. Deliberately we left it out. We know that the answer will be negative, which means that the two numbers that we will use as the coefficients of the two components will have different signs. Let us also say that the coefficients are large, and we will therefore use products of prime factors in helping us to find the value of the two coefficients. We are not saying that they are actually large. I am making use of this tutorial to demonstrate to a candidate what he or she may do if he or she thinks that the coefficients are very large and they are not easily manipulated in order that we may see the two middle coefficients that easily. So I'm saying that if you think it is too large, this is what you can do. But I am not saying that 84 is a very large product. I'm saying if you get a product, maybe another product of 2560, then you could probably make use of the same process. But I'm not saying that it is necessarily very large. We need to use a combination that will give a difference of negative 8. So that is our target, negative 8. We know that the product will be the same as 4 times negative 21. But our target numbers will also give a sum of negative 8. Remember that if the two numbers that we need to add have different signs, then we have a subtraction problem. So we will have a subtraction problem because when we multiply, the product is negative, the two numbers will have different signs, so we will have a subtraction problem. Now we have the product of each prime factor. Now we have each one of the numbers A and C written as a product of its prime factors. So we have 4 written as 2 times 2 and 21 written as 3 times 7. Therefore, the entire number will be 2 times 2 times 7 times 3, or 3 times 7 if we prefer to put them in numerical order. the number that we are taking a look at is actually 84. However, let us say that we do not know what the number is. We still should be able to figure out what two numbers will give this -8. And no doubt that irrespective of what the number is, that 4 times 21 is the same as 2 times 2 times 7 times 3. Why? Because 4 is 2 times 2 and 21 is 3 times 7. And we need to use all of these numbers that we have here in arriving at the two components that we will use to replace that -8. In arriving at the two middle coefficients, the values of the numbers are not the only factor that we may consider. The middle coefficient is even. There are only two ways to get a sum that is even. 1. Add two even numbers. 2. The two numbers are odd. And we are sure that we cannot get two odd numbers from this situation that we have here because we have even factors. So we have even factors, so we cannot use a combination that gives us two odd factors. Therefore, in order to get our even number here, we will have to use two even numbers. So we are saying that not that it has to be so sophisticated, that if we are attempting to find that middle coefficient or those two middle coefficients, the value of the numbers is not the only thing that we can use. We may make use of the fact that the number is even, or if it is odd, we make use of the fact that it is odd. But in this particular case, it is even, and we are making use of the fact that it is even. We can arrive at an even number in only two ways. If we add two even numbers and if we add two odd numbers. We definitely have to conclude that the two numbers cannot be two odd numbers because of the presence of the even factors. Therefore, we are sure that the two numbers must be even. For this to happen, the two 2's have to be separated. So of the two numbers that we are using, one of the 2's will have to be in one of the numbers, and the other 2 will have to be a factor in the other number, else we will not have two even numbers, and we really need to have two even numbers. There are therefore only two possibilities. One, if we take the 2 by itself and multiply by 7 and 3 and leave the other one alone. So we have 2 times 7 times 3, which will give us 42, and then we have 2. So one option is 42 and 2. Why, this question now, why can't we use 2 times 2 and 7 times 3? Because an even with an odd will give an odd, and we are sure that it will not work because we need an even. So we take 2 with 7 and 3 and we leave the other 2 by itself. We are sure that that one will not work. 2 and 42 will not give us -8 by subtraction. Therefore, it is the other one that we should consider, which is take the 2 multiplied by the 7 and take the 2 multiplied by the 3. So 14 and 6. We can be sure that 14 and 6 are the two numbers that we should use, and we have determined that without considering the value. And that is what is really flexible about mathematics, that although we intend to identify the two values, we do not have to use or to concentrate so much on the values, but we can use another attribute of numbers to arrive at our answer. And we have used the fact that the middle term is even, and we need to arrange these two numbers that we are about to capture from this product. We have to choose them in such a way that the two of them are even. And we have concluded that the two numbers are 6 and 14. 2 7s 14 and 2 3s 6. Later on, we may take a look at the value and see that 6 minus 14 actually turns out to be a negative 8. So we are sure that the two numbers are actually correct. But we could have concluded already based on the fact that that is the only other way that we can get to even numbers. There we have the expression written with its two middle components that we have received on the previous slide, the two coefficients of a positive 6 and a negative 14, and we have them resolved already. The first terms have common factor of 2y. So 2y is the common factor of the first two terms. And we will divide each term by the common factor, and this, as a matter of fact, is our intended mental operation. 4y squared divided by 2y is 2y, and 6y divided by 2y is equal to 3. Of course, 2 into 4 is 2, and 1 into y squared is y. Then we have here 2 into 6 is 3, and the y's will cancel. 2y plus 3. And the second pair has a common factor of negative 7. We always use the sign that begins the second pair, a negative 7. And of course, the common factor the highest common factor of 14 and 21 is 7. And there's no common factor of y because there's no y present right here. So, negative 14y divided by negative 7 is equal to a positive 2y. Negative divided by negative is positive, and a negative 21 divided by a negative 7 is a positive 3. So 2y plus 3. And again, we have common factors. The common factor is 2y plus 3. We will finish our factorization by taking a common factor of 2y plus 3. And by so doing, the other factor will be 2y minus 7. And I'm hoping that at this stage, there's no mathematics camper who imagines that the 2y minus 7 just appears in the other pair of brackets, because we have shown before how we divide each term by its common factor, arriving at a situation that is similar to this one on a few occasions. And throughout the tutorials, we will return to the actual division so that we will be constantly reminded throughout the tutorials that this particular step is not magical, but it is very much in keeping with the fundamental principle of factorization, which is we need to take the common factor and divide each term by the highest common factor. The order of the middle terms is different from the one on the script. So in this particular case, whereas when we were working the one on the script, we use a negative 14, then a positive 6. We use a positive 6 and a negative 14. Turns out that the two factors are the same. However, the order is different. And we know that multiplication is commutative. Therefore, the order that we multiply numbers or expressions in does not affect the result. So we are sure that although these factors are arranged in a different order, that we are still correct. And we have, maybe for 100 times, we will have difference of two squares. And we will factorize each one of them as we encounter each one. This expression is in the form of a difference of two squares that we are expected to factorize at sight. Look and factorize. Just write down the factors. This is a single step problem in which we consider the square root of the squares. So this one square is 1. The square root of 1 is 1. And the other square is 9x squared. The square root of 9x squared is 3x. And we will throw 1 and a 3x into brackets. And then we will separate them by a positive sign in one and a negative sign in the other. And that's all there is to it. And we say before that the order of the signs do not matter if the negative one is here and the positive one is there. The number of marks that are allotted to a problem is a good indication of how many steps are to be taken in solving it. It is highly unlikely for more than 1 mark to be allotted to a difference of 2 squares problem. We should therefore not take more than a single step in solving it. And we see students solving or factorizing difference of 2 squares, and they have resolved the middle coefficient, which is 0, into its 2 component coefficients, which are additive inverses. We'll take a look at that before we are through with these tutorials. But that is not completely necessary, because the examiners are expecting us to be able to just look at one of those difference of 2 squares and write down the factors. If, however, a candidate chooses to go through the long and lengthy process of resolving the middle coefficient, which is 0, into its 2 components, which are additive inverses, and then to factorize, then the candidate will still get the full marks for that problem, which is 1 mark. And the candidate would no doubt have taken about 3 or 4 steps, which is not really what is expected in the examination. Here we have another trinomial. The product of A and C is 3 times negative 6, and that is equal to negative 18. We therefore know that the numbers will have different signs, because what? The product is negative. The numbers will have different signs. And because B, which is the middle coefficient, is negative, we know that the larger one is negative. So product is negative, numbers will have 2 different signs. The sum is negative. That tells us that of the 2 numbers that have different signs, the larger one is negative. Although some candidates may figure out the 2 coefficients of the middle components immediately, let us take a look at the possibilities. We have 18 multiplied by 1 is equal to 18, 9 2s 18, and 3 6s 18. Or we usually say 3 6s are 18. The larger one has to be negative. We know that the larger one is negative because when we add them, the result is negative. So we will have, as here, 18 1, 9 2s, and 6 3s. But because the sum is negative, we put for each case the larger one is negative, the larger one is negative, and the larger one is negative. And those are the results that we have there. The one that gives us the correct negative 7 value is that one, negative 9 plus 2. As a matter of fact, usually if we are taking a systematic approach, well, as a matter of fact, some candidates do not really need to take a systematic approach. But if we are taking a systematic approach, as soon as we encounter the one that gives the correct answer, then we do not have to go to the other one. But for these tutorials, I'm just demonstrating all of the possibilities. So we could have stopped as soon as we found the correct pair, negative 9 and positive 2, and they are the 2 coefficients of the component middle terms. We have them resolved, and we will factorize by grouping, by taking the first pair first and the HCF of the first pair is 3x. 3 can go into 3 and 9. X can go into x squared and x. 3x is our common factor. And what do we do? As usual, we divide each term by the highest common factor. And as I said before, we will not always require that the step be taken mentally, but sometimes in the tutorials we will return to the act of demonstrating the division of each term by the highest common factor by also including the intermediate step on the slide, as we have right there. And the highest common factor of the second pair is 2, and we will divide each term by 2 in the good old spirit of the first principle of factorization. What do we do? Divide each term by the highest common factor. 3x squared divided by 3x is equal to x, and negative 9x divided by 3x is equal to a negative 3. And the other one, a negative 3. Then that one is a bit simpler. Cancel these twos. X. 2 into 6 is 3. Very quickly. There is no difficulty. Then we have another common factor of x minus 3. So we will take the common factor of x minus 3 and we will divide each term by the highest common factor. Right, just as I promised that we will include the intermediate steps so that the candidate will be able to see them. And as we go along, I'm making another promise that sometimes we will not include the intermediate step but just assume them, and in such a case we will write them down, or a short representation of those intermediate steps, because we cannot explain a mental process without some representation. So divide each term by x minus 3. What do we notice? That 3x remains right there. That's the only thing that we have left. And when we take out those, we will have a positive 2 remaining. And that is the end of that one. Finally, we have another trinomial. We will finish up this section with that trinomial. And we are saying, in this case, the product of A and C is 6 times negative 2. That gives negative 12. 6, negative 2, negative 12. The product is negative. When the product is negative, the two numbers have different signs. And B, which is the middle coefficient, is positive. That means of the two numbers that have different sign, the larger one is positive. So let us consider the pair of numbers that will give a product of 12. There we have them. 2 times 6, 12 ones and 4 threes. The larger one will be positive. So the 12 will be positive in it, the 6 will be positive, and the 4 will be positive, and we will see what the sum is, or difference, depending on how we look at it. So 12 minus 1 is 11, and we do not stop until we arrive at the correct one, which is that one. A term that is not accompanied by any coefficient, as we have right here, we know that the coefficient is 1. Also, there is really no need to go through a long, lengthy, or technical process if the coefficients of the middle components may be identified immediately. So, no need to go through the entire length of the system if we can just look at it and identify the two component coefficients of the middle term. We will finish up our factorization process by taking the highest common factor first of the first two terms. We have 6, we have 3. Common factor is 3. We have x squared, we have x. Common factor is x. So 3x is the highest common factor of the first two terms, and we will again divide each term by the highest common factor. On the other hand, we have 2 is our highest common factor right there, and we will divide each term by the highest common factor, as we have right there. Now, take note that the sign that begins the second pair is positive on this occasion. Therefore, we will use a positive sign for our common factor, as we have done on a few occasions. When the second pair begins with a negative term, we use a negative term or a negative sign in our highest common factor. Now that it begins with a positive sign, we should have no reservation using a positive sign in our highest common factor of those two numbers, which represents, of course, the second pair. And then we may take a look at it under the microscope. 6x squared divided by 3x. 3 into 6 is 2. X will cancel into x squared and we have x. And then we have a negative 3x divided by negative 3x. Any number divided by itself is 1. But do not forget that we have this negative sign right here. So negative 1. Again, we have 2 into 4x, 2x, and 2 divided by 2 is 1, and do not forget that negative sign. Right. And no doubt, we have a common factor of 2x minus 1 that we will take, and we will divide each term by the highest common factor, and those are gone, 3x, and then those are gone, and we have a positive 2. So that is the end of our tutorial. We imagine if there is no other extra fancy footwork to discuss, then we will be at the end of this one, and we will move merrily onto another tutorial. This is no doubt 1C, so we will move on to 2 part A.